Hello advanced algebra students, and welcome back to another video lesson as we look at solving equations with radicals today. I think you're going to find this very familiar to some information from last chapter. However, we've got to talk about something called extraneous solutions, extra solutions, if you will, and how do they happen and why do they happen? Okay, but first let's look at a few warm-ups. If you would, why don't you pause the video and try these 4 questions, please. All right, question number 1, simplify the following, right? The 5th root of all of that. Okay, the 5th root. Well, the 5th root of negative 32 is going to be negative 2. The 5th root of p to the 10th is p squared. Plus 4th root of 16 is 2, and the 4th root of p to the 16th is p to the 4th. Can I combine those together? Do they have like terms? They do not. That is now simplified. And again, if you needed to change this to, being it to the 1/5 power, you can look at it that way as well to see if that might help you. Number 2, rewriting that. So again, to rewrite it, simplified exponent. Doesn't want a radical. But we're going to first rewrite it using one radical so that we can see what radical we're using. 5 times 4 times 2, right? We got to multiply the roots that are on the shelf. 20 times 2, so that's the 40th root. The 40th root of y to the 100th, or we'll change it to use a simplified exponent, y to the 100th, all raised to the 1/40th power. And we multiply, meaning we're going to get y to the 100 over 40 power, 100 over 40, but we've got to simplify that. We've got to make sure we simplify. 1 over 40, if we divided by 10, we would get 10/4. Still not simplified quite yet. Dividing by 2, we're going to get 5/2. Y to the 5/2 would be a simplified exponent. So a little bit of work on that one. All right, let's look at number 3. Is it positive, negative, or is it going to be undefined? The 5th root of a negative 625. That's going to be a negative value. We talked about that one a little bit yesterday. Negative 5 squared, that's positive. Negative 5 to the 8th, that also would become positive. And a positive times a positive means we would have a positive answer. Negative, or the opposite of this. So negative 7 to the 13th. An odd number to the 13th power. Odd to the 13th. That's going to make this chunk odd, and I take the opposite of an odd, or the opposite of a negative, the opposite of a negative is going to also make that one positive. And then the last one over here, because we're raising it to a negative 1/5 power with a fraction. Remember, we talked about how we're not really going to have to work with those. And so this one is undefined. We're not going to spend too much time on that one. We're more worried about these two over here. And then number 4, can you explain why 4th root of negative 100,000, 10,000 is undefined? Well, again, there is no such way to get x times x times x times x can never equal a negative value. It's impossible. Okay? So again, mini test on Thursday. We're getting geared up, just trying to add some of those review questions. Now, last chapter, we were asked to solve something with rational exponents. 4x to the 1/3 minus 6 equals 10. How did we solve that? We moved the 6 over, we divided by 4, right? And then we raised everything to the reciprocal. How are we going to solve it in this chapter? Well, guess what? The same steps. We're going to add 6. We're going to then divide by 4. And whenever we have like a cubic root of x equals, so what is that? 16 divided by 4 is 4. Right? It's a similar process. To undo something that has a third root, we raise both sides to the third power. We raise both sides to the third power. And x would equal 64. So the nice part about a lot of this information is that it's the exact same process. We're still trying to isolate the variable, and it's going to be very similar, right? That last step might just be slightly different with some of the rules that we have in our new chapter. The other thing we have to be careful of is this extraneous solution. All right, this one's not in your packet, but I want to talk about what it looks like. So if we were to solve, we would first subtract 2, and we are left with the fourth root of x equals negative 5. That fourth root of x equals negative 5. How do we undo the fourth root? Well, we raise both sides to the fourth power. Raise both sides to the fourth power. And in doing so, x is by itself, and we get x equals negative 5 times negative 5 times negative 5 times negative 5 is 625. Right? And it's going to become positive. Anytime I take a negative to the fourth power to an even power, it becomes positive. Now we would think, okay, what's the big deal, right? So what? I got an x equals, like I did everything right. We always need to check our answers in this particular chapter because we might get what's called an extraneous solution. It looks like it should work, but when we plug it back in and we simplify, you're going to notice something happens. Now remember, what we talked about is that if we take the fourth root of 625, we're only worried about the positive real roots here. Fourth root of 625, that's 5. 2 plus 5, that's 7. Does 7 equal negative 3? It most certainly does not. And so we say this problem has no solutions because 625 is extraneous. 625 is extraneous. It's like an extra solution that doesn't really fit when we plug it back in. Okay? A solution that does not satisfy a given equation, but algebraically it really should because the steps we used were correct. Now let's try these two. Okay? Why don't you pause the video and give these two a shot? All right, letter A. We've already got the square root, the radical sign isolated, and it's just a square root, so we're going to square both sides. I'm left with whatever's underneath, 5x minus 10, that equals 9. And then I'm going to add 10 to both sides. And 5x equals 19. When I divide by 5, we get x equals 19/5. Now we should always check that. And seriously, we do need to check them. Okay, let's plug it back in. 5 times 19/5 minus 10. That's all underneath this square root. 5 times 19/5 is 19 minus 10. 19 minus 10 is 9. Square root of 9 is 3. Does that equal what was on the other side to 3? It most certainly does, and so we can say x equals 19/5 is indeed a solution. Second one, letter B. Again, we've got the radical sign isolated. It's the sixth root, so we're going to raise both sides to the power of 6. X plus 3 equals 64. Negative 2 to the 6th is 64. When I subtract 3 from both sides, I get x equals 61. Let's plug that back in. The sixth root of 61 plus 3, or the sixth root of 64. When we simplify that, that's going to be positive 2 The original equation said it should equal -2. Therefore, it is extraneous. It's an extra one. So we say this problem has no solutions because it's an extra solution. It doesn't work. All right, now there's a pattern maybe that you're noticing, right? Here are the two that we've seen so far that have extraneous solutions. What conclusion can we make? Well, hopefully you noticed that before we even squared or fourth or did some sort of power to the other side, we've got a negative over here with an even root. And what we talked about in the last couple of days is that we can't find some number underneath here that when we take it to an even root, that's going to give us a negative. It's not going to work. So anytime you have an even root and a negative value, there's going to be extraneous solutions and no solutions. Okay, pause the video and try these two. All right, letter C. We have to subtract 2 first. And then we got to be careful about that subtracting sign right there. So what we're left with is the opposite of that fourth root of 2x minus 4 equals 8. So we've got to divide by -1 to get rid of that. And we have the fourth root of this 2x minus 4 equals -8. Now that should probably tell us something, right? We're going to get no solutions. We should get no solutions because something's going to be extraneous. So if I take both sides to the 4th power, a little bit challenging without a calculator here, but we should see that that's going to be extraneous, right? It's going to give us no solutions. If we try this one over here, -12, and we get -12, we have the 5th root of 5x minus 3 equals -2. Now be careful. Got a negative over there, but we have an odd root. So if we raise it all to the 5th power, we should still get some solutions that work. Negative, should be a negative there. -2 to the 5th is -32. Negative times negative times negative times negative times negative. It's going to give us a -32. 5x minus 3 underneath. Add 3 to both sides. And we're going to have 5x equals -29. Or x equals -29 fifths. X equals -29 fifths. Now we need to make sure we check that by plugging it in here. Let me do a different color quickly. All right, 12 plus the 5th root of 5 times -29 fifths minus 3. Does that equal 10? 5 times -29 fifths gives me -29 minus 3 underneath this radical, or the 5th root of -32 with a 12 out front. Does that equal 10? The 5th root of -32. As long as it's an odd root, we can find that, which is -2. 12 minus 2 is indeed equal to 10. So that does work as a solution. All right, and hopefully you're seeing these patterns and recognizing what's happening. Now, what happens when they ask you to solve for a variable? In this case, to try and get k by itself. Well, notice we've already got the square root isolated over here. So to undo that square root, we square both sides. Or v squared equals 2mk. How do I get this k by itself? we've got to divide by 2m to both sides. In doing so, we do have k by itself, and it will equal b squared all over 2m. So I hope that as you've viewed some of these today, you do recognize a little bit that we've done some of these solving problems in last chapter. They should be a little bit familiar to you on how to isolate the radical and how to go about solving. If you do have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.